A very good afternoon to all. जैसा कि सर का लास्ट प्रेजेंटेशन था डार्क वेव, तो हम लोग डार्क वेव से डायरेक्ट शिफ्ट करेंगे डायोड रेक्टिफायर पे। डार्क वेव टू डायोड रेक्टिफायर्स। डायोड रेक्टिफायर्स, तो जैसे कि हम लोग जानते होंगे आप लोग डायोड क्या होता है। सर किसी को पता है डायोड क्या होता है?
यस सर,
यूनिडायरेक्शनल डिवाइस होता है जो करंट को एक ही डायरेक्शन में फ्लो करवाता है, ठीक है। और हम लोग जैसे जानते हैं कि हमारे घर में कुछ जो वोल्टेज सप्लाई जो आता है वो क्या आता है, एसी आता है या डीसी आता है? एसी आता है, जो कि क्या होता है हमारा अल्टरनेटिंग नेचर का होता है, मतलब पॉजिटिव साइकिल फिर जाके नेगेटिव हाफ साइकिल इस तरीके से आता है। लेकिन कुछ ऐसे हमारे डिवाइसेज होते हैं जो क्या करते हैं, डायरेक्ट एसी पे वर्क नहीं कर पाते हैं, तो उनके लिए क्या करना होता है, जो डीसी पे वर्क करते हैं तो उसको डीसी में डायरेक्ट वो कैसे कन्वर्ट होगा, तो उसके लिए हम लोग यूज करते हैं रेक्टिफायर। तो उसी के बारे में आज हम लोग बात करेंगे कि रेक्टिफायर क्या होता है। तो जैसे कि हमारा ये, जैसे कि मैंने अपना इंट्रोडक्शन भी दिया था, तो जैसे माय नेम इज राहुल कुमार, आई एम असिस्टेंट प्रोफेसर इन इलेक्ट्रिकल इंजीनियरिंग डिपार्टमेंट फ्रॉम सरसा इंजीनियरिंग कॉलेज। तो ये दिस इज आवर सेशन आउटकम एट द एंड ऑफ द सेशन। Students will learn about the rectifiers. He will learn about types of rectifiers and also will get information about use of rectifiers. These are the prerequisite knowledge in which students must know about voltage, current, also about the circuit theory and knowledge about semiconductor theory. As Rakesh already taught about the semiconductor devices, in which he tried to explain about the diode and PN junction diode. In our session, we will also include PN junction diode, and we will explain more how the diode will convert AC supply to DC supply. So introduction. So as I told, rectifier is an electronic device which converts alternating current to direct current. Now, types of rectifiers. Here are two main types of rectifiers. One is half wave rectifier and second one is full wave rectifier. Further, it is also categorized in two more types. One is center tap full wave rectifier and second one is full wave bridge rectifier. Now we will explain about half wave rectifier. As name suggests, half wave. As we know, in AC supply or any electrical signal, this is my AC input signal, as you can say signal. This is positive half and this is negative half cycle. So as our name half wave, this is a complete wave, and this one is half, and this one is also a half cycle. So here name suggests it will rectify half of the portion of the circuit. So here this is a circuit diagram of the half wave rectifier, in which we applied input AC source, and then after we connected here a step down transformer which will lower the voltage level of the transformer, which is 230 volt to 5 to 10 volts, because we know that our diode works mainly on the range of 5 to 10 volt. And after that, here is connected one PN junction diode, and as I told, diode conducts current in from anode to cathode. It means it will conduct positive half cycle and blocks negative half cycle. So when we apply here, this is, as I told, we will apply input as a AC source, and AC source is alternating in nature. We assume at instant it will, here will be positive and here will be negative. When here will be positive, diode will work as forward bias, and if diode will work as forward bias, and on that time we will get output across the load. And at instant when here, if here it will be on seconds half a negative half cycle, here will be negative and here will be positive. On that time, diode will work as reverse biased, and there will be no output across the load. So we can see here, this is our input cycle, input signal, and we got output. As when diode is forward biased, we got output, and when diode is reverse biased, there is no output. Here output is 0 across the load. Now we will come on the full wave rectifier. As I told, there is two types of rectifier and full wave rectifier. One is center tap full wave rectifier. In center tap full wave rectifier, we use here center tap transformer. Here in the secondary winding, it is one winding is centrally tapped. It means what? If we here voltage will be distributed equally, and here we use two diodes and one load resistor. So when we will apply AC voltage to the circuit, then at a instant it will be positive, and it will be positive here, and one time it will be negative. So when it will be positive, our diode D1 will be forward bias and it will conduct current across the load line this way. And when at instant it will be here negative and here positive, on that time what will happen? Here will be, this diode will be forward bias. Why? Because it will be, this is minus, this will be plus, then this conduct, P terminal is connected to what? Positive terminal is connected to anode terminal. That will be, this diode will be forward bias. And on that time here is negative, and this P terminal will be reverse biased. And so that in this way we will get the output across the load from this diode only, and this diode will be reverse biased. So let's see. As I have not taken waveform for this, but this waveform will be just like this is our input voltage, then output will be just like this. Names suggest what full wave rectifier means. Output will be once when we will apply positive half cycle, then output will be like this, and when negative half cycle will apply, then the D2 will be conduct and D1 will be as a reverse bias. Then we will get output like this, and this will be continue like this. Now we will talk about full wave bridge rectifier. As you have seen that in earlier half wave rectifier we have used only one diode, and in full wave in center tap rectifier we have used two diodes. Now here this is a full wave bridge rectifier. Here we have used four diodes, and they all have one same work. It will convert AC alternating current to direct current. So here I have four work. And when we will apply positive half cycle, then here two diodes will be conduct. Now how this you know, for when one diode will be forward biased? When positive terminal is connected to where? With P type terminal is connected to cathode terminal, then it will be forward biased. So here when you will see, here we will apply positive half cycle, then diode D1 and D3 will be forward biased, and D2 and D4 will be reverse biased. So then whatever output we will get, this is if this is full wave rectifier, it means it will give output in full in both cycles, as positive half cycle and negative half cycle. So here will be our D1, D3 output will be D1, D3 and D2, D4, and so it will be continue. These are the comparison charts regarding half wave center tap and bridge type of rectifier. Then I have conducted here 9 more of diodes. In half wave rectifier 1, center tap 2 and bridge type 4 diodes are connected. Transformer necessary in all, and maximum efficiency of half wave rectifier is only 41%, almost 41%, and center tap 81%, and bridge type also 81%. Now a question arises, if the efficiency of both the diodes are same, then which diode we will prefer as a rectifier circuit? It will depend on our application where we will use which type of diode. This is the conclusion. We can understand the importance, necessity and use of rectifier. Now the question is, you can answer this question. What is the primary function of diode rectifier circuit? Can you answer? To convert AC to DC. Now second question, a half wave rectifier, how many diodes are used? One diodes. These are the references. You can look. Thank you all.